And the other fundamental concept about thermal radiation is it obeys same law of light, namely it travels in a straight line, right? It may be reflected from the surface. Suppose the cold substance is placed in the side of hot body inside an enclosed space. The cold body intercepts the radiation emitted by the hot body. It's obvious, like as we were talking about this, it can be reflected and at the same time it's moving in a straight line. So the same thing could happen on the hot body. The fraction of radiations falling on the body may be reflected, which is known as reflectivity, we call this. And the fraction on which observativity, and the fraction that's transmitted is known as transmittivity. So we have reflectivity, observativity, and transmittivity, which are three properties of the thermal radiation. The first one is when they are reflected, we call them reflectivity. When they are observed, we call them observativity. And when they are transmitted, we call them transmittivity. And as I said, when I was starting about the lesson, we were talking about heat exchanger. So let's see some interesting points regarding heat exchanger. So here there are devices used to transferring heat energy from one fluid to another fluid. It could be hot gas or steam or liquid. So heat exchangers can be classified on basis of type of fluid flow arrangement and method of heat transfer. So let's start from the type of fluid flow arrangement. The first one is parallel flow heat exchanger. We'll have counter flow heat exchanger, and we'll see cross flow heat exchanger. These are based on their flow arrangement. We said that we can classify them based on two categories. The first one is based on type of fluid flow arrangement, and the second one is the method of heat transfer. So let's start from the flow arrangement, which is parallel, counter, and cross flow. So we do have a parallel flow heat exchanger. It's also referred to as concurrent or parallel steam exchangers. The hot and the cold streams are enter together at one end, flow parallel to each other. They enter at one end, they flow parallel to each other in the same direction and leave together at other end, and they leave together at the other end. So with parallel flow, the temperature difference between the two fluids is larger as the entrance end, but it becomes small at the exit end. At first it's larger, their temperature difference, but when they are at the exit end, it becomes smaller. The overall measure of heat transfer driving force, the log mean difference is less than the counter flow. Like this one is kind of different concept, and try to cover it by yourself. It's kind of broad. If I got enough time, I will try to come up with this log mean temperature difference with detailed calculation. And the second one is counter flow heat exchanger. It's also known as counter current exchanger. In this type of in this type, hot and cold fluid flow parallel but in opposite direction. If you remember, in parallel they were entering the same side and they were also moving in parallel. But here, even though they move in parallel, but it's in opposite direction. So we call it counter flow. We call it counter flow heat exchanger because it's opposite direction. The hot fluid entering at one end of heat exchanger flow path, and the cold fluid entering at the other end of flow path. So the hot fluid enter at the other end, and the cold fluid also at the other. So it's in opposite direction, but they are still parallel. So it's the disadvantage of the counter flow heat exchanger is the first one is thermodynamical superiority in other flow arrangement, and also high temperature change in each fluid. You can see cross flow heat exchanger. We have the hot fluid here. And also we don't have the what we call counter flow. Okay, this one is, I think this one is for counter flow, but let's go for cross flow. In cross flow type, one fluid flows perpendicular to the second fluid. This is totally different. As you can see, we don't have the hot fluid here. We don't have the cold fluid. We don't have the hot fluid here. So they are what? At perpendicular direction. We call them cross flow because one fluid is crossing the other fluid. So we call this thing cross flow heat exchangers. Cross flow arrangement, mixing of other fluid stream may or may not occur. When these fluids cross, mixing may either happen or may not happen. It depends on the application that we are working for. These heat exchangers are typically used for heat transfer between gas and liquid, like the convection, right? So most of the time between heat transfer between gas and liquid we use these two things.